Okay, this is a 9G talk. The 9G meaning I'm going to have to talk fast. Not 9G meaning Oracle 9G, 10, 11, 12G. I introduced myself by saying I founded the Top Quadrant in 2001, first US company doing things explicitly with semantic web stuff. And the original title of my talk, the one in the agenda, was all SKOS related. So I've extended that to talk about other semantic technology driven systems, including 15926 driven systems. I'm here because I'm on my way to Athens from Oslo, where I'm working with a Norwegian company doing some deployments. I'm celebrating the fact that we delivered and deployed a major environment system this week. And I'll talk a little bit about that. So I'll introduce myself, give a little bit of an overview of what top rate is. I want to skip those slides really to be able to get into topics that have come up, and I've tried to contextualize my talk to connect with what's been said already. Yeah? So deeper dive into one case study might do that, and then I'll have some thoughts about what kind of work that your consortium should do in order to help what we're up to in the world. So I've introduced myself. I actually work with NASA as well on QUDT, which is ontologies for quantities, units, dimensions, and types. I'm the lead architect and ontology model at EPIM, which is Energy and Petroleum Information Management Association. And the thing to know about Top Quadrant, to make it a brief introduction, is we innovate with Sparkle. We push the Sparkle standard further. We have Sparkle representations in RDF. We do Spin, which is an inference engine in Sparkle, where you can say question mark this, and a class can define rules on every instance. We have Sparkle Motion, which is a data flow scripting language. We have SWP, which is a way to generate web pages with Sparkle, and a way to actually generate LaTeX for the QUDT handbook. I'm outputting 4,000 pages from NASA handbook based on ontologies, and that's also being used. SWP is also being used to generate queries. I have a query generator built in that technology as well, where a model of what the query should do is then the basis of how the query gets generated. SWA is a way to build jQuery kind of things, to build user interfaces with Sparkle technology. So that's what it means to be an innovator with this technology. So how do you make a programming language out of Sparkle? It sounds crazy, but that's where we've gone, yeah? And we are known in the world for Top Rate Composer. We make a platform now with Top Rate Live, we have done for some years. We make a vocabulary management system called Enterprise Vocabulary Net, which is not just SKOS based now, it can deal with any kind of ontology support. And we have a life sciences solution now called Top Rate Life Sciences Insight, based on TBI, which is using extensions to D2RQ to build a virtual data warehouse. How do you make data stores look like one data store? So that's the introduction. This is a leave behind. It's a slide which you can look at later that explains our technology stack. And just note that we've got Sparkle web pages up there, we've got Spin, we've got ways of representing Sparkle web services and having them automatically accessible through REST. We have a way, as I said earlier, to do things with Sparkle Motion, to have a data flow language happen, bring this source in, bring that source in, do some inferencing, make another graph. All kinds of things can happen in that scripting language. There's the stack in more detail. Again, I leave this as a takeaway in the interest of time. Choosing some of the customers to talk about for this presentation, I thought I would talk, since I'm working there a lot, EPIM, the Norwegian Petroleum Consortium, and Syngenta, which is a life sciences company, and another company in this picture, which is Mayo. Somewhere there's Mayo. I won't talk about NASA, so we'll move on to talking about Mayo and Mayo, and then EPIM, and I think I'll cover Syngenta a little bit. Why are they using our technology? Well, in the case of the Mayo Clinic, it's to be able to connect information about education, about things that live in their content management system, things that research people are doing, clinical information of other kinds, so clinical practice information. In the case of Syngenta, it's reaching into databases like Chemi and Chebble and CIDR and making it look like one and following navigation. So it's kind of like the talk that came up earlier. Here we're using spin map technology to map a database to a neutral model. That mapping can then lead to the generation of SQL that gets fired at the database. Triples come back into the D2RQ connector, and we are able to build a UI and navigation of all of that. EPM is the big thing I'm going to talk about. It gets into some graph management issues and 15926 transformations. And there's a project mentioned here at the end, OTPP. This is a pension fund company in Canada that are using SKOS based. Well, they started with EVN as a SKOS based thing, but they added support for metadata, master data management. It turns out that the SKOS world often will need master data management as well, as you probably find in FAO. So this is Mayo Clinic. Enhanced search. Why do they want to have vocabularies? It's to make search better. It's to be able to generate the right attribution, annotations on things that live in content management systems. They're using top-rate live and top-rate EVN for that. And the architecture, it went live actually, something to mention here, 5th of January, 5.6 million page views per day. So I'm only going to talk about projects that are live, commercial things here. This is, you can look at this later. Gives you a picture of where how the architecture is. There's top-rate EVN. There are some servers handling the content enrichment and search enrichment and some content management there. And across all these companies, we notice these kinds of sizes. They have between 5 and 100 vocabularies. You'll hear me talk about, it's very interesting, the words we use. A vocabulary is something that isn't going to, it's like a data set that isn't going to change. Yeah? At one time, we had to use the word because people were scared of the O word. In America, you couldn't use it. You'd be walked out of the room if you said ontology. So a lot of people working in America had to say vocabulary. What it means is ontology, a lot of the time, right? When I say graph, I think the word you've been using is data set. But there are something like 15 kinds of graphs we have. Rules graphs, script graph, UI graphs, bridge graphs, proxy graphs, et cetera, et cetera. So knowing how to provide authorization, a question that came up earlier, you have to know what kind of graph you're busy with, yeah? Is it a data set? Is it a schema? Anyone can look at a schema probably, yeah? But not at a data set. Those things will come up. The complexity that they have involves a lot of this authorization, quality, constraint checking. We find ourselves dealing a lot with rules in our systems, therefore spin. How do you make the rules more intimate with the triples? That's what the spin W3C submission we made several years ago with spin is allowing to have happen. We can have rules associated, as I said earlier, with the class, and that fires on behalf of every instance, but we can even be clever than that and put rules on properties, and we do a lot of that kind of thing in our systems. So we move on in the interest of time. I mentioned that people take EVN further. Here we see an example of an asset management system. This is you might see a winch there on this movable facility. It's going out to an oil rig. It's doing some test drilling. The way that is fitted with its equipment is managed in an extension of EVN. This was built in less than a week. Actually, it was built in 2 or 3 days, the initial version. There's a guy in Oslo putting this together and delivering it in June, I think, yeah? So how to build an asset management system that normally would be millions of dollars from IBM is an interesting problem to solve now with this slant technology we're all interested in, yeah? So some of the ways in which people get busy with our technology is to write, as I said earlier, services. And here you can see an example of a service written in as a SKOS template. The template body is doing a transitive property over the SKOS border. Notice the two arguments. This makes this a parameterized template of the kind that I think you mentioned earlier in your talk. We hold all of this as an RDF model in its own right. Everything you see is tripleized. And this way we can do some interesting meta-level things with our system, yeah? And have the same authorization on these kinds of graphs as we would want to have on other kinds of graphs. This is an executable graph, so we have in our authorization permissions framework a checkbox saying you're allowed to execute this service, yeah? If you satisfy any constraints that are mentioned within the same instance of a service. Syngenta, some people call them a death science company because they're into insecticides and things like that. So now that we want to call them a life sciences company because we care about insecticides as well as other things. So we have a situation here where we had to connect a number of databases to make it look like one database. And what they were amazed at was the ability for this technology to allow them to connect another source very quickly. What would have taken 6 months for their data warehouse people to do things could be done in a matter of a week or two, or even less in some cases. So that is about connecting warehouses and other disparate data. D2RQ is in this picture, but also transformations based on BID technology. This typically requires us to follow a traversal of a graph. So here we see disease improved by drug, has target, has pathway, includes protein, coded by a gene. It's often the case that we'll have multiple searches like this where we're putting this together either as a script to have a federated search go across multiple databases. And some of those things could be Sparkle endpoints. It often is the case that there are databases, and we've had to unravel how things happen with some of these huge things like Kepi and Kempe, yeah? Which are not the easiest things to integrate. So here we are now in Norway, and there are several things going on here. We delivered about 1.5 years ago a reporting hub, which I'm going to talk about first, which took drilling information and production data from the North Sea oil platforms off the continental shelf here of Norway and reported to the authorities, such as License to Share, which is a body that wants to have reports on who's doing what on what platform, and then it will decide who gets what cut of the profits, yeah, based on what's happening. But there's also the Norwegian government itself, FM itself needs to have various reports. So this picture here tells you that this was the start of our involvement, the environment hub. I got these things run the wrong way. This slide should have reporting hub on the left, I think. No, this right. Environment hub is the thing that's the second one over, which is what we're doing now. We delivered this this week into production, and what that does is monitor the emissions, things like acute pollution to the sea or to air, how much oily water is going out, what kind of carbon dioxide, nitrogen, etc. It's just what bad things are happening. NH4, ammonia, and various things like that are reported in the environment hub. The reporting hub I mentioned on the last slide, which is drilling in production, and the next project we're currently having to deliver is a logistics hub, which is tracking containers, how containers move from place to place, and put into ports, and loaded onto ships, and sent to the oil rig. It's a huge system that's kind of like the system we saw with the tunnel, yes, but we're getting sensor data from RFIDs, and we're tracking the movement of containers. Yeah, that project is going to be delivered this year as well. So this is the reporting hub. It's got a lot of XML coming in from the oil rigs, the daily drilling report, the monthly production report, the daily production report. They get processed as RDF on that central piece of the picture there, and the reports are sent either in XML or PDF to the various authorities and licensed partners. The technology that's involved in doing that, well, first I described the scale of this, about 300 million triples in the next 4 years. Not many users, 40 plus concurrent users. They have about 2,000 XML schemas, and there's a service that has to have high availability and security for all of this. Yeah. So this happens using proxy ontologies. We take an XML schema, we generate an ontology from it. That's the top part of the picture. We use that ontology to ingest an XML schema. What it says is, I see that you're an element, and if you have another element, I understand that that means that you're either an object property or a data type property. Because I've got that tag in my proxy ontology, I can understand how to instantiate a model against the R model from the first step. So that it happens dynamically for all the XML, and this is what a environment, sorry, I'm onto Environment Hub now. There's a similar kind of picture for the Reporting Hub, but this is dealing with wellbores and various aspects of the structure types that have been monitored, such as the one I mentioned, oily water discharge, produced water analysis, there's hazardous waste, all kinds of things going on. So how does this happen? I'm not expecting you to read the Norwegian here, but this is a table that we generate with a Sparkle query. I'm going to show you a little bit of the query behind such tables to emphasize the need for benchmarks that test all kinds of strange things that go on. Notice, here we have if statements in the select body. We have a bind going on, splitting the string there is one of our functions. Notice it's a magic property in the middle there. Here we have summations going on. Why do the summations go on in an inner select rather than the outer select? It's because I think in this case I might be calculating average or summations and doing arithmetic. And there are unions in here as well. So like 70 to 80 of these queries. Some of these queries were generated from the ontology of the report. And the reason to stress this is going back to this table. When you think about queries in the linked data world, it's not just that you want to get the data back, you want to put it into a table or a structure. And there are things like Jasper reports that you've probably heard about. And there are things like Crystal reports. What is the equivalent in the semantic web world to something like that? Yeah. So the benchmarking that I'm trying to suggest we ought to get into again is constructing not just a set of results like we get from a query, but a set of results that can be a table as complex as this. Sometimes there are I call it a heterogeneous table where each row could be different. These rows are predefined rows. They're talking about different kinds of water, production water, foreign. I don't know Norwegian enough, but these are different types of water, and each query might have a separate query value. So there's a thing to be figuring out there. Yeah. So, in the interest of time, I'm going to just mention something called magic graphs, which is an innovation we've recently done for this project. A magic graph is like a view in Sparkle. What it's doing is a query view transformation. The magic graph syntax has three parts to it. The first part is the schema map. The second is the field year subgraph we want. And the third is the target schema we're transforming into. In the bottom of this picture, you see field year graphs for every field in the North Sea here for every year. And those graphs can be draft. They can be versioned to be official. They can be under QA. So there's a whole workflow thing going on there. But then there are things happening in the interface model where analytics are going to be run against composite graphs. So we're dealing with a lot of graph manipulation and transformation. And the thing to figure out here might be a Sparkle working group question, is how to have a standard for view technology at the time you see in SQL. So without spending much time in there, I'm now into this, how it happens. I've gone under the covers here. This is a sparkle motion script where we see the use of the provenance ontology on a, this is making liftingly 15926 graphs into the interface model. The work is done in the very last, in the second last module, which is a call to a script that I'm going to show. Bulk load is simply a bulk load in Sparkle terms. The script going on in the lift uses a reflection technique, give me all the classes in the model. That's a magic property there which reflects over the model. Give me all the properties in that class, and while you're doing that, check that who I am, I'm authorized to access that property. So some of our authorization rules go behind those functions in the predicate position, which are magic properties in this case. Here we see the graph being accessed in the last part of that query, and we have a construct going on to build a graph within the execution with execution space of the Sparkle motion script. And what happens is it saves that graph in the last module. How many triples do we have here? About 4 million in the interface, in the integration model. The overhead of 15926 is about 10 to 1 because it's a full E ontology and because it's a meta ontology. It even represents things like inheritance as a class. I'm 5'6". I'm a member of a spatial part of the class of things that are 5'6" in the world. So for every property value, there is a class. But think about that, 5'6" in 2013 or 2014, sorry. So I have a temporal part of it, yeah? So that's what's going on with 15926. That complexity goes away when we lift the model into the other world, yeah, of the interface model. Logistics hub, I mentioned it already, tracking containers brings its own problems with authorization. Who can view a CCU higher? Who can view a CCU itself? And that changes depending on what leg of the journey you're on. So there's a lot of dynamic authorization stuff going on here. And I'm going to end by saying Sparkle is more of a query language. We can do model-driven applications with it. There are different kinds of solution types, and we're going to need different kinds of benchmarks if we're doing something real here. Yeah? You can follow me on Twitter. Some of my presentations are on ScribeD. I do have a site called linkmodel.org where I'm busy with things like Vein and Vogue and D-type and QEDT stuff, and I stopped. In time, or I didn't get one of these.
No.
That's why
I didn't dare give you one. But just do that.
Was it 9G or 11G? Or too much.
It was very interesting. So there must be some questions. So first, is there any question here?
Well, I have a comment. So you would be asking from a benchmarking initiative, you want to see views. And you want to see long queries. Okay, we do, for example, OpenFacts, where queries don't touch so much data. They go to the data sets that you well know about Campbell TV and stuff. Yeah. And they have often 70 triple patterns and lots of optionals and unions and stuff. And then when you execute them, you notice that your performance is bounded by compile time, in fact, to figure out the join order for that. So, so is this the sort of direction where you would like us to go?
Yeah, certainly I would like to. One of the things that we're currently doing is some regression testing over all these queries. And I need a framework for putting that together which is more compliant, if you like, with how other benchmarks are done. But I also want to test the parts of typical patterns. One of the things we do is try to, just like there are design patterns in the world for object-orientedness, and there should be query patterns as well. And the first person to write that book is going to sell a lot, I think. Yeah? And I'd like to see those query patterns named properly and tested against the conformance set of queries. Yeah?
Right. If you're talking about, okay, a lot of these have an analytics dimension, so business intelligence type workloads. You must be familiar with DPCH and DPCDS from the relational BI side. And Okay, so we have kind of transplanted in the LDBC lots of these challenges that have to do with executing queries like that in graph, I guess. And of course, they do sometimes contain data views, for example, which is common. Any other wishes?
I will have some. Maybe I shouldn't email. I think I'm delinquent at not having that as the final slide because I didn't get a true sense of the importance of community. But I will communicate that to you when I've thought about how to distill this into some meaningful request. Yeah.
Right.
Yeah.
Because you might want to review some stuff that we are producing, like intermediate.
Yeah. No, that I will do.
Yeah, specifically, I mean, there is the BI work now that we are working on from the social network benchmark. That's, I mean, that kind of resembles, I think, what you were showing with the with these complex tables or whatever.
The complex, this kind of stuff.
Yeah, that kind of stuff. Yeah, that's what you will find in the BI work now.
Oh, interesting. So I should check
things,
that.
yes. What does bind mean again? What is that?
It's a assignment. It's assigning a list here. This is say, make me a list with all those water types, then split it, take each thing. Bind it, start with 1.1.
And by the way, so top red, is that the technology of itself, or do you use other kind of repositories?
Top red based on Jenna, and then we use SDB. We're working in one project we're working with Allegrograph, that was the first one we pulled from them. The Environment Hub is working with MySQL. Logistics Hub is working with Oracle. And we need Oracle Sparkle 1.1 and Oracle desperately, yes?
Support.
Great, because it was meant to be with us in March, so maybe we should talk afterwards.
Okay, so I would like to thank you again, but in the interest of time, like you said, move on to Simon Jeff.
Yeah.